All right, welcome. Today we are diving deep into one of the most just reality-shattering concepts in the entire universe, black holes. I mean, these things are the ultimate cosmic puzzle, right? A place where the rules of physics as we know them just seem to, well, they just fall apart. So let's get right into it. And it all really boils down to this one single question. What in the world happens when gravity gets so strong, so ridiculously powerful, that light itself can't get away? I mean, think about that for a second. This is the question that's been driving physicists crazy for ages. And the answer? Well, it takes us right to the very edge of everything we think we know. So, what's the deal?
Okay, so first things first, we have to get on the same page about what a black hole actually is. And let's go ahead and bust a huge myth right out of the gate.
You know that picture in your head, the one of a big, empty vacuum cleaner in space? Yeah, throw that out. A black hole is the complete opposite of empty. You got to imagine a mind-boggling amount of matter, like a star 30 times bigger than our own sun, crushed down into a space so tiny it's basically nothing. And all that stuff in one spot creates a gravitational pull so powerful that, yeah, absolutely nothing gets out.
You know, every prison needs a wall, right? Well, for a black hole, that wall is what we call the event horizon. Now, this isn't some physical thing you could, crash into. It's more of an invisible line in the sand. The moment you cross it, the speed you'd need to escape is faster than the speed of light. And, well, since nothing in the universe can beat light in a race, there's just no going back. It's a one-way trip.
Okay, so that brings up a really obvious question, doesn't it? If these things are totally black, if they swallow every last bit of light that touches them, how in the world do we even know they exist? It's a fantastic question, and the answer is, well, it's not about seeing the black hole. It's about seeing the mess it makes.
Yeah, this is the exact puzzle that astronomers face. It's like they're trying to spot a black cat in a room with no lights. You're never going to see the cat directly, so what do? You look for the evidence it leaves behind. You look for its footprints all over the cosmos.
So here's how we do it. We actually find them by watching the chaos unfolding around them. Picture this. A star wanders a little too close, and the black hole's incredible gravity starts yanking on it, just tearing it to shreds. And all that gas and dust doesn't just fall in silently. Oh no, it gets whipped up into a frenzy, spiraling inward faster and faster, heating up to millions of degrees. It creates this absolutely brilliant glow, not in light we can see with our eyes, but in X-rays. And our telescopes can spot that X-ray signature from across the universe. That's the smoking gun. That's how we know some invisible monster is hiding in the dark.
Okay, so we figured out how to spot them from afar. But now, let's get a little closer. Let's imagine we're actually approaching that point of no return, the event horizon, because this right here is where reality starts to get really, really weird.
So, thanks to Einstein, we know that what you see depends completely on where you're standing. Let's say you're watching a friend's spaceship fall toward a black hole from a safe distance. To you, it would look like their ship is slowing down, and down, and down. The light from it would stretch out, getting redder and dimmer until it just sort of freezes on the edge, fading away forever. You would never ever see it cross. But for your friend inside the ship, everything feels totally normal. From their perspective, on their clock, they just sail right across that invisible line. No drama, no big event. It's just wild. Two totally different experiences, and somehow they're both true at the same time.
But just because you cross the horizon doesn't mean you're in the clear. The gravity gets so intense that it creates these things called tidal forces, which would literally stretch you out like a piece of spaghetti. It's a process called, well, spaghettification. Now, for a truly supermassive black hole, like the one at the center of our own galaxy, its event horizon is so huge you could actually cross it without being torn apart. The real danger zone, the part where you get stretched, only starts much, much closer to the center, about 93,000 kilometers out. It's kind of crazy. You pass the point of no return long before you hit the point of certain doom.
But look, whether you get spaghettified or not, once you're inside, your fate is sealed. Inside that event horizon, space and time are warped so completely that every single direction, up, down, forward, backward, they all point to the exact same place, the center. Firing your rockets is useless. Trying to turn around? Impossible. Every possible future, every path you could possibly take, all of them end at the singularity.
I know. This all sounds like something straight out of a crazy sci-fi movie. But believe it or not, the idea of black holes isn't some new, wild theory. It's actually the result of hundreds of years of brilliant scientific detective work, with each generation building on the ideas of the last. I mean, this hunt really kicked off way back in 1783 when a guy named John Mitchell came up with this idea of dark stars. But the real game changer was Einstein in 1915. His theory of general relativity gave us the math to actually make sense of it. Then jump forward to 1958, David Finkelstein came along and defined the event horizon perfectly as this one-way membrane. And then in the 70s, the great Stephen Hawking just flipped the whole script again, proposing that black holes aren't even completely black, that they can leak energy and, over an unimaginable amount of time, just evaporate.
And all of that history brings us right here, to today, to the very edge of physics. It brings us to the deepest, most fundamental questions that black holes force us to ask about what our universe is actually made of.
Okay, get ready for this, because this is one of the most bizarre and shocking ideas in all of physics. It's called the no-hair theorem. And what it says is that once a black hole settles down, it is ridiculously simple. It doesn't matter what fell into it, a star, a spaceship, an entire alien civilization, all the complexity, all the information, what scientists call the hair, it's just gone as far as the outside universe is concerned. The only things you can ever measure about a black hole from the outside are its mass, how fast it's spinning, and its electric charge. That is it. Everything else is lost.
And right there, at the very heart of this simple object, lies the singularity, a point that is supposed to have zero size and infinite density. And right here, our best, most successful theory of gravity, general relativity, just breaks. It completely falls apart. It spits out nonsense answers, like dividing by zero. The singularity isn't just a wall in space, it's a wall in our knowledge. It's the universe screaming at us, hey, your physics is incomplete.
So, where does that leave us? All these paradoxes, these impossible ideas, wrapped up in black holes, led Stephen Hawking to make this fantastic, kind of funny suggestion. He said the universe seems to have a built-in chronology protection agency. A set of rules that prevents things like time travel paradoxes from messing everything up. A way to make sure the universe stays safe for historians. That keeps cause and effect working the way they should. And that really leaves us with one last big idea to chew on. Are the bizarre rules of a black hole just some strange glitch in the cosmic code? Or are they a fundamental feature, there to protect the very fabric of reality itself?